or in interval notation it would be negative infinity to 3. So for number 1, this is on the second page on 13.2. The reference points are negative 1, 1 over b. So notice how 1 over b, because b is 1/2, 1 over b is 2. It's a reciprocal. Okay, so now the k value here is 3. So that means that y's are going to be adding 3 to the y's. Okay, so negative, the x's stay the same. Okay, and then so 2 plus 3 is 5, 1 plus 3 is 4, 3 plus 1/2 is 3.5. And that's what we're going to graph. So there are the 3 dots, the 3 points, and then I just drew the horizontal asymptote on y equals 3. So now I'm going to connect the points. So like that, and it just gets closer and closer to the horizontal asymptote. The domain is all reals, and the range is all y's greater than 3, so I could write it in interval notation like this. So in this problem number 2, again, negative 1 is 1 over b. Since b is 1 over 10, then 1 over b would be 10. 10 over 1. The h is negative 4, so that means that x's are going to be, we're going to subtract 4 from all the x's. So we have negative 1 minus 4, negative 5, and then 0 minus 4 is negative 4. The y's stay the same. 1 minus 4 is negative 3. Okay, and that's it. We're going to graph it. Alright, so there are the 3 dots plus the horizontal asymptote. Because k is 0, because there's nothing right here, right? K is 0, I drew the asymptote at y equals 0, okay? So now we're going to connect the points. It's a very steep curve because the base is 1/10, and when you take the reciprocal, it's 10. So let me get the right color. And so it goes like this. Almost like an L. So steep. Okay, so the domain, all reals, and the range is all values, all y's greater than 0. Alright, so in this problem, h is positive 1, a is negative 2, because that's right here. This is the a, this is the h, and k is positive 2. Okay, so that means that x's, we're going to subtract 1 from the x's, and for the y's, we're going to do negative 2y plus k, which is plus 2. So let's do the transformation. So we're going to have negative 1 minus 1, negative 2, and then 2 times negative 2 is negative 4, plus 2 is negative 2. 0 minus 1 is negative 1. Negative 2 times 1 is negative 2, plus 2 is 0. 1 minus 1 is 0. And then negative 2 times 1/2 is negative 1. So 2 minus 1 is 1. So now we're going to graph. Alright, sorry, let me make a correction. I just realized h is positive 1, so this part is right. But when I wrote it right here, it should have been plus 1, and I put minus 1. So that's going to change the x values. 1 minus 1 is 0, so let me erase them real quick. So 1 minus 1, or negative 1 plus 1 is 0. 1 plus 0 is 1, and 1 plus 1 is 2. Okay, so now it's correct. So now we're going to plot them. So 0, negative 2 here, 1, 0, and 2, 1. And draw the asymptote at y equals 2. Right there. And then connect the points. So something like this. The domain is all reals, and the range is everything below 2, so we're going to write negative infinity to 2 like that. Alright, so in this problem, h is negative 2, a is 1, and k is 3. So x, we're going to subtract 2 from the x, and we're going to add 3 to the y. because it's going to be 1 y, right? So it's just y, because a is 1. So now we're going to transform the points. So negative 1 minus 2 is negative 3. 4 plus 3 is 7. 0 minus 2 is negative 2. 1 plus 3 is 4. And 1 minus 2 is negative 1. 3 plus 1/4 is 3 and 1/4. Alright, so here's the points, and then I already drew the asymptote on y equals 3 because k equals 3. So now I'm going to connect the points. Whoops, off a little bit, so let me go like that. Alright, so the domain is all reals, and the range is all numbers greater than 3. All y values greater than 3.